Hey guys, welcome back. So what we're looking at today is lessons 14 and 16. We're going to be working on both of them. Lesson 14 is distances on a coordinate plane. So let's go ahead and jump right in. So what we're looking at here first is just really making sure that we know how to write these coordinates. So for A, X is always first, so 4, comma, and then we look at our Y value, which is up here at 3. So A is the point 4, 3. Then for B, we still have an X value of 4, but now it's down at negative 3. For C, we're at an X value of 3 and a Y value of negative 5. For D, our X value is negative 4. Our Y value is negative 3. And for E, our X value is negative 5, and our Y value is positive 3. So those are our points. Like I said, always remember you're taking and doing the X values first and then the Y values. So part 2, answer these questions for each pair of points. How are the coordinates the same? How are they different? How far away are they from the Y-axis, to the left or to the right of it? How far are they from the X-axis, above or below it? So A and B. So remember A was 4, 3, B was 4, oops, not negative, 4, negative 3, C was 3, negative 5, D was negative 4, negative 3, and E was negative 5, 3. Just that way we don't have to go back to the grid. So A and B. So both A and B, they have the same X coordinate. So same X coordinate. Opposite Y coordinate. In terms of from the Y-axis, how far are they? So that means to the left or right. They are both to the right 4 units. So right 4 units. And in terms of the X-axis, so above or below, so looking at our Y values, A is above by 3, and B is down by 3. So they're both the same distance, but one's above, one's below. All right, for B and D. So B and D, they have the same Y coordinate. So same Y, opposite X. How far away are they from the Y-axis? So B is 4 right, D is 4 left, and then in terms of the X-axis, they're both down 3. So they're down 3 from the X-axis. All right, and last but not least, A and D. So A and D, they are opposites. A right 4, D left 4, A up 3, D down 3. So they have the same value, it's just they're opposites of each other, so negative versus positive. All right. 3, point F has the same coordinates as C, except its Y coordinate has the opposite sign. So C was the coordinate 3, negative 5, and it says it has the opposite sign, so that means F will be, F will be the point 3, 5. So let me come back up here. 3, 5 is right there. So that is F. Okay. So then how far away are C and F from the X-axis? Well, they are both 5 units. So 5 units. What's the distance between F and C? Well, if C is 5 below and F is 5 above, 5 plus 5 is 10 units. Okay, point G has the same coordinates as point E, except its x-coordinate has the opposite sign. So point E was -5, 3, so it's going to be 5, 3 for E. How far away are G and E from the y-axis? So y-axis is looking at our x values, so that means they're both 5. So 5 units. And once again, we're going to have 10 units for their distance. So point H has the same coordinates as point B, except it's both coordinates have the opposite sign. In which quadrant is H? So if both of its coordinates have negative, so let's say, so B was 4, -3, so B was 4, -3, so H is -4, -3. Which quadrant, 1, 2, 3, or 4, has both signs negative? So if, or both its signs are opposite, so actually, sorry, I read that wrong. So both its signs are opposite, so it'd be -4, +3. So it's got one negative, one positive, so this would be in quadrant 2, because our x value is the negative. All right, so that is what we are looking at in terms of the coordinate plane and finding those distances. So now we're going to jump into our second lesson. So we're looking at the greatest common factor. So the greatest common factor of 30 and 18 is 6. What do you think the term greatest common factor is or means? So what do we think? What does it mean? So it means the largest factor that the numbers share. So for the second one, find all the factors of 21 and 6, then identify the greatest common factor of 21 and 6. So 21, things that multiply to give us that. We have 1 and 21. We have 3 and 7. That's it. For 6, we have 1 and 6, and we have 2 and 3. So which factor do they have? So the greatest common factor of 21 and 6 is going to be 3. So our GCF is 3. GCF is your key word for this lesson. All right, for 28 and 12 is the next one. So 28, we could do 1 and 28, 2 and 14, 4 and 7. And then for 12, we have 1 and 12, we have 2 and 6, we have 3 and 4. So what's the greatest factor that they both share? That would be the 4. So its GCF is 4. All right, a rectangular bulletin board is 12 inches tall and 27 inches wide. Elena plans to cover it with squares of colored paper that are all the same size. The paper squares come in different sizes. All of them have whole number inches for their side lengths. What is the side length of the largest square that Elena could use to cover the bulletin board completely without gaps and overlaps? So we want to find the greatest common factor between 12 and 27. So 12, we'll write it down below where we're explaining how the solution is related to GCF. So 12, we've got 1, 2, 3, 4, 6, and 12. I just wrote it from up here where we'd already done it. Make it a little easier. 27, we have 1 and 27, and we have 3 and 9. So these are our greatest common factor, or our factors. So our greatest common factor is going to be 3. They both have 3. So that means the square is 3 inches. 3 inches wide. So we could use 4 by 9 squares to fit within the rectangle. So 4 by 9 squares to fit. Now, how is this solution to the problem related to greatest common factor? So The side length of the square must divide 12 since the squares must stack vertically to reach exactly 12 inches, and the side length of the square must also divide into 27. So we have to find that one factor that can go into both. And so that's why we use the greatest common factor, because we want the largest. We don't want to have to deal with itty bitty tiny little squares, because obviously we could have just done 1 by 1 squares and we know it'd work, but that'd be a lot of squares. All right, so if you guys have any questions, feel free to ask. Have a wonderful day.